The inverse function occurs when we switch the x with the y values. And if we look at this graphically, you'll see a reflection about the y equals x graph. Now, the symbol for the inverse function is like the usual function notation, but there'll be a -1 power at the top. This implies inverse of a function. Let's start off with problem 1. So we're going to first change this f of x to a y. So all along, it's been that. We just haven't used the y. We are now for algebraic purposes. Next, we switch the x with the y. And this is because the inverse means literally switching the x with the y. Not only the variables, but all the values that go with those. Now we solve for y. I like to make it a habit of putting the variables first. We solved for y, and so we found the inverse. To make it official, we're going to do some transforming. So we put the inverse function notation and we change that y back to an x. And so the inverse function is going to be this. So here's the graph of the original function, x minus 5. Here's a graph of the inverse function that we just found, x plus 5. And here is the mirror image, the equation f of x equals x. So this acts as our mirror image, and you'll note that there are reflections of each other. So the original function and the inverse function are a mirror image reflecting off of the equation f of x equals x. Let's do another one. We express this first with a y. We switch them around. We solve for y. Before you tell me that you're not good at functions, anytime you graph, you're using functions. Now, let's do some manipulation. I hope you're okay with me saying there's a 1 in front of this x. And I hope you're okay with me moving this fraction a little bit to the left, and this x a little bit more prominently. And this is the inverse of the function. So it's going to be half times x. Here's the original function, f of x equals 2x. Here's the inverse of that function, 1/2 x. Here's that mirror image again, right? That mirror that reflects them. So that mirror being f of x equals x, or y equals x. And you'll note that, again, we have reflections of each other. That is a reflection of that one. So be aware that an inverse of a function is a reflection of that function, and it's a reflection based off of this mirror, right? F of x equals x. Part C, we're going to go ahead and set it up with a y. We're going to switch the x with a y. This becomes a typical middle school two-step problem is what they're called, because they require 2 steps. The first step is addition or subtraction. In this case, I want to subtract both sides by 3. Keep in mind the good habit that when you do rewrite this, that you go ahead and actually put the variable x first, so we can have a slope intercept form, which you were taught in pre-algebra and algebra 1. And then the second step is to either multiply or divide. In this case, we're dividing. We can write things in a cleaner way. And then, of course, don't forget to make this an inverse, f -1, and then make this back into an x. Again, we note that they are reflections of each other, and in particular, when they do intersect, they intersect at exactly one point. This is very fascinating to us. Remember, the green line in this case is that mirror image, f of x equals x. Sorry, the mirror itself, not the image, the mirror. For those of you wondering about part B, I'm going to go ahead and skip to the chase on this one. So hopefully you set it up right, you switch things around, you do the first steps. I'm taking you to pretty much the end. So we get to a point in our work where we get this. We're going to divide everybody by 2. And we get this, right? So we got to do the inverse. There's a 1 in front, and there's a 2, so there's a 1/2. And then 4 divided by 2 is 2. So this is the inverse of that function. That function being this function. So these are inverses of each other. The process for finding the inverse at this level for us in Algebra 2 is pretty typical and doesn't deviate much at all. You know, you're going to go ahead and replace your f of x into make it look like a y, switch the x to the y, use algebra skills to solve for y, and then make sure you simplify if possible, and then bring back that inverse function notation.